let's focus on what projectile motion, JAMB Physics class. So in this video, we are going to look at what's projectile motion, the two type of motion associated to what projectile motion, which are the what horizontal motion and the vertical motion. Then we have to study them very well. After that, I want to look at what formulas associated to what projectile motion. They want to solve some basic calculation. So you want to stick to the end of this video so I can take down every single thing. Now this video is going to have part 2, projectile motion part 2. We are going to dive down deep into what measure calculation. So this is just like introductory aspect, so to help you understand the fundamental aspect of what projectile motion, right? So make sure you watch this video and watch the other part of the video so I can get what the full concept. So let's get into what is projectile motion. Projectile is any object thrown or released into space that travel along a curve or parabolic path. At any point in time, a projectile motion is characterized by two motions. One, the horizontal motion at constant velocity, when the linear acceleration is equal to 0 meter per second square. Number two, vertical motion, the up and down, with constant acceleration, where gravitational acceleration is what g equals to 9.8 meter per second square. Do you understand? So now when we talk about projectile motion, it's the movement of an object in a curved path or in a parabolic path like this. So now this is the graph here. So when you throw an object here to move from here down here, right? So this is the movement of an object in the parabolic path, right? So now this projectile motion have two types of motion. The first one is called horizontal motion, horizontal what motion, and what vertical what motion. Right there, horizontal motion and what vertical what motion. So first of all, let's look at what the horizontal what motion. Horizontal what motion. Let's look at what the horizontal motion. Now, in the horizontal motion, there are two things you need to understand here. Now, there is no acceleration. So the linear acceleration is equal to what? 0, right? The linear acceleration is equal to what? 0. Now, when the linear acceleration is equal to 0, the velocity does not change. There's what? Constant what? Velocity. Do you understand? Now, the reason why the linear acceleration is 0, because in a projectile motion, there's only one acceleration that is acting on it, which is called the G, gravitational pull, acceleration due to gravity. Do you understand? Acceleration due to gravity. And in acceleration due to gravity, now because we're talking about horizontal, that is moving straight, like this, is moving straight. So the acceleration due to gravity does not actually have effect on the horizontal parts. Do you understand? So what I want to understand here is that my A is equal to what? 0 meter per second what square. And if A is equal to 0 meter per second square, then my velocity is constant. The velocity, the initial velocity is what? Is constant. Initial velocity, you can see that initial velocity, initial what? Velocity is what? Is constant. Initial velocity is what? Is constant. So there are two things you need to know here. Then we also have formula when it comes to what? Horizontal motion, right? Remember when you draw it like this, remember the stuff move like this, right? So here we have what my initial what? Velocity here. It's okay. Now here we have the angle of projection, right? So here you're talking about what? Ux, that is initial velocity at what? Initial velocity at the horizontal what? Plane. Because we have what? Initial velocity at what? At vertical what? Plane. But here we let you focus on this one here. So sorry, here we have what? Just u, not ux, just u. Initial what? Velocity. So the initial velocity can be resolved to what? The horizontal component and what? The vertical what? Component, right? So here we are going to focus on what? On the horizontal what? Component. In the horizontal component here, how do you resolve it? Here we have the initial velocity at what? At the horizontal component. Here we have what? The initial what? Velocity. So this way I want to use SOHCAHTOA. SOHCAHTOA. Idea. So now here is what is the adjacent. Let us say this stuff is here, right? Here is what is the adjacent. Here is what is my what hypotenuse. Just here is what is my adjacent. Go and watch my video on trigonometry. You understand it here. When we talk about what right angle or triangle. So here is what is the horizontal, which what is my adjacent. Then this one here, which the initial velocity is what is hypotenuse. So that's why I'm using what cos theta. So cos theta is equal to what my adjacent, which is ux over what u is okay. So if you make this guy solve the formula, you get what us equals to u cos what cos theta. It's okay. So now this is the what formula for when it comes to what the formula for horizontal what motion, right? So now in horizontal motion, you understand that there is no acceleration, because the acceleration that acts on the body on projectile is what g, acceleration due to gravity, and acceleration due to gravity do not have effect on horizontal what motion. So that's why I say that a acceleration is always equal to what 0. Just now if acceleration is always equal to 0, then the uniform velocity, that is the velocity, the initial velocity is going to be constant. Just because here we have a equals to what change what velocity over what t. Just so if here is 0, then it's here going to be what constant. That is mean. Just because here we have a equals to what v minus u over what t, right? So if here is already equals to what 0, let me just explain to you so you understand this here. If here is already equals to what 0, because it's always 0 when it equals to the horizontal, because no acceleration is acting on it. So if here is already equals to 0, go to 0 equals to v minus u over what t. So if you cross multiply, what will up here? T times 0 is going to be 0, right? So it will be v equals to u. So v minus u equals to what 0, right? Can you to the answer here? V equals to what? Equals to what? U. Then the velocity, there's no change in velocity. So at the horizontal motion, acceleration is always equal to what 0. There's no acceleration happening on it. And if my acceleration is 0, my velocity is constant. That is, change velocity is constant. So the initial velocity is constant. Why? Because the initial velocity equals to what final what velocity, right? Now because at first there's always what a velocity that they used to project it upward, right? So the velocity does not change when it comes to what horizontal what motion, right? And the formula to use what is ux, means what initial velocity at what at the horizontal component. Although in vertical motion, I still go to have on what vertical what component, but here we are talking about horizontal what motion, right? And in horizontal motion, us equals to u cos theta. How do we get this one here? It's through this diagram here, like this. They use what SOHCAHTOA to get it. Just so this is everything about what horizontal what motion. Is not difficult. Just but understand this guy, and what and this one. So these are the three main things when it comes to what horizontal what motion. So there's not much calculation on that horizontal what motion. So let's move to what vertical what motion, which we are going to dwell upon. Vertical motion. This is we talk about the up and down what motion. Up and down. So upward motion and downward what motion. Again. Now in downward motion, yeah, we know that acceleration due to gravity actually have impact on it, right? So acceleration due to gravity is always what act on it, which is what 9.8 what meter what per what second what square. Idea. So now when we talk about vertical motion, there's always what acceleration what due to what gravity. Just so there's always change in what velocity. So you understand here, there's always change in what in velocity. That is, the final velocity is not equal to what to the initial what velocity. Hope you understand. So there is always change in what in velocity. Okay, what it means at each point here, the velocity tends to what change. The final velocity is not equal to what to the what initial what velocity. Get this thing clear, right? So now in the if you check this here, when you project like this, it's okay, right? So now because we are talking about vertical here, it's okay. We are talking about what vertical here. So we're going to be what ux. It's okay. We're going to be what ux. So here we have what theta. It's okay. Now this part also is the same thing with this part here, which was u what x. Remember for the horizontal here we have what, sorry, uy. What am I doing here? Uy. Here we have what u what x, right? So now here we have to concentrate on the what vertical what motion, the vertical plane or axis, vertical what axis. Here we have the x axis and what y axis. The x axis is the horizontal what motion, while the y axis is vertical what motion, which deals with up and downward movement, right? Acceleration to gravity always have effect on this. Hope you understand. So if you check very well, if you look at SOHCAHTOA, you have to use sine. What is sine here? This side that is opposite to what, to this angle here, is called opposite here, right? Y this one is the hypotenuse. So it's going to be sine theta. Sine theta is equal to what? My opposite, which is what? Uy over what? My hypotenuse, which is u. Is okay. So make it so it's solve the formula here. We make the guy solve the formula here. We have what uy equals to what? U sine what? Theta. So the horizontal velocity, initial velocity is what? U sine theta. Is okay. Why the uniform velocity is what? Is u sine what? Theta. Why the horizontal, which was u is equals to what? U cos what? Cos theta. Is okay. Most times they use all this in calculation, so that's why you want to pay close attention to them. Do you understand? So what's the science here? Now, because we have called the upward and downward motion here. This way we are going to use what? Motion under gravity. Do you understand? Motion under what? Gravity. Remember, we have what called equation of motion, right? We also have equation under gravity. We have to use equation under gravity here. Do you understand? So now equation of motion under what? Gravity. That's what we are looking at. Equation of motion under what? Gravity. So remember, we have what? Three equations of motion. The first one is what? Is v equals to u plus at, right? Here we have x equals to ut plus half at squared, right? Here we have what? V squared equals to u squared plus 2ax. Now this is called linear what? Motion, right? So now remember, we have called the upward motion. Upward what? Motion. And in the upward motion, that is the object is moving upward, and whenever the object is moving upward, what happens here? It acts against the what? The acceleration due to gravity. Do you understand? It acts against what? Acceleration due to gravity, which is g, or gravitational what? Acceleration. Do you understand? So in the upward motion, my a is always equal to minus what? G. My x is what is height, right? Remember, x is what is distance, horizontal. But when we talk about data, we talk about what? Height of the object. Do you understand? So now when we talk about upward motion here, you do what I'm going to use here. A equals to minus g, x equals to what? H, right? So in projectile, when it comes to vertical movement here, you replace it. So here we have v equals to u minus g t. Is okay. So I'm going to use this one. So this is first formula, in the upward motion, right? Now the next one is what? Is h. Whenever you see h, put what? H. So it will be h equals to what? ut minus half gt what? Square. This is that. There you have what? V square equals to what? U square minus 2gh. This is that. So these are what? The three equations of motion when it comes to what? The upward movement. Now why the downward movement here, when it comes to free fall, do you understand? Is acting along what? It's not opposing what? The gravity, right? Is falling due to free fall here. So in the downward movement, downward motion. And in downward motion here, a is equal to what? G, and what? H equals to S equals to what? H. Is okay. So what happened here? You change it minus what to plus. Say what? V equals to what? U plus GT. Is okay. Then what? S equals to UT plus RGT square. Right? Then what? V square equals to what? U square plus 2GH. This is that. So you have to use all these ones to what in calculation. You are using all these ones to what in calculation. So this is everything about what the vertical what motion. This is everything about what vertical what motion. So we have done the definition of what projectile one. We have done what the horizontal motion, and we have done what the vertical what motion. Now let's look at what formula associated to what projectile what motion. Formulas associated to what projectile what motion. So now when we talk about projectile motion, here are the four formulas here for solving projectile motion questions. See that for a projectile motion under objects projected at an angle theta to the horizontal. So in the sense that when you project an object at an angle, it's okay with an angle here. Look at the angle here when you project it like this, right? You get the point when you get to what to the maximum height, right? So before you want to get to it down here, right? Here we have the range. So here we have the time to reach the maximum height. The time is set to what reach the maximum height. T equals to U sine theta over what G. That is your answer. T small letter t equals to U sine theta over what G. Right? Time of flight. So the time when it gets to here to touch the ground, that is called time of flight. So going to be 2 times 1 here because here is the halfway. This time it takes what to reach the maximum height, right? Then when you get down, so the time of flight is the 2 of them. So that's why I say 2 U sine theta over what G, right? Then the maximum height. This height you can calculate maximum height. So this is maximum height here. The maximum what height, right? So H maximum can be H what maximum equals to U square sine square theta over 2G. So this is what maximum height. Please pay attention to all this in here because when it comes to what solve a problem under projectile, when the object is projected under what an angle right to the horizontal, these are the formulas we want to use. Then the horizontal range from here to here, U square sine 2 theta over G. So in my next video here, we have to what solve some problem under this one here. But let's look at what some basic problem when it comes to what projectile motion, especially what in the vertical what aspect, right? So in the next video, we are going to solve more problem on this. But let's look at what some basic question under what vertical what motion. Let's look at these 2 questions. So you are going to use these 2 questions to end this part 1 class, right? In part 2, I want to solve more questions. Use those projectile what motion, right? So now these questions are a little bit technical. They are not like the type of question when it comes to what motion under gravity, right? There's a little bit difference here, so you want to pay close attention because it's a projectile, and projectile have what initial vertical velocity and what initial horizontal what velocity. So initial vertical velocity and initial horizontal velocity, this is what makes it differ from the other one, right? Motion under gravity. So it's an arrow is horizontally projected from top of a tower with an initial velocity of 15 meters per second. Now this one you're seeing here is called horizontally projected. So this is called horizontal initial velocity. So this is called what the U what X, which is called initial horizontal what velocity. Just horizontal. Remember here we have the horizontal velocity which was UX and vertical what velocity U what Y, right? So therefore the velocity given to you as I say, is it horizontal or vertical? It is horizontal. How do you know it is horizontal? Is what an arrow is horizontally projected from the top of a tower with an initial velocity of 15 meters per second. So this one here is what 15 meters per second what square. Can you see that? If it reaches the ground 7 seconds later, calculate the height of the tower. Calculate what the height of the tower. Now, we talk about the height of the tower. That is the height at which it was what projected. So we are going to use So now, if the arrow was projected down, that is it's under free fall, right? Because it's under free fall, what is going to happen there? They didn't make any statement about what vertical initial what velocity. So my vertical initial velocity here is what is 0 meter per what seconds. Is it clear? So remember, when an arrow is moving down, is under what vertical what motion, right? So to calculate the height, so they say that the time it takes to the time it takes to reach the ground is what c equals what 7 seconds, 7 what seconds, right? My g, what is my g equals what 10 meter per what second what square. Hope you understand. So if you look at what the equation of motion here, you can use this one here. H equals to u t plus half g t square. Why we use this one here? They say the height of the tower, right? We know our time, right? We know our g. But this one you are seeing here is going to be ux. So h equals to what? U, so it's going to be what? U y t plus half g t what square. Can you see that? Uy. Just because it's called vertical initial what velocity. And the vertical initial velocity what is 0 because they didn't say anything about the vertical initial what velocity. They only say horizontal initial what velocity, which was ux. Hope you understand. Please try to understand this here because students don't actually understand all this in here. That's why they fail in the exam. So now with just understand here, my uy is what 0. So it will be h equals to 0 times 7 plus half times 10 times 7 t t square. My t square, my t is 7. So remember, this one is going to be 0, right? This one going to is what is 5. So it will be h equals to what 0 plus 5 times 7 raised to power 2 is what 49, right? 49 times 5 is what 245 what meter. That is the answer. 245 what meter. Now let us say we change value here to be what 16 seconds here. So go ahead and solve this question for me. Please don't ignore. I know that you say you know this here, I will solve later. That is how some of you misbehave, right? Pause the video now and try to do it. Now look at something here. There's something now. The best way to actually learn something by doing it. This is called passive. This is called active what learning. If you watch this video now, just take me, it's called passive. But when you solve the question, it's called what active. Do you understand? So pause the video, use my value here and solve this question. Leave your answer at the comment section, right? If you don't understand, leave a comment section. But if you understood what I've just done here, please leave a comment section that you fully understood what I've done, right? So let me move to our question 2. Let me move to our question 2. You say that a ball is projected horizontally from a height of 20 meters above the ground with an initial velocity of what 0.4 meters per second. Look at something here. Let analyze the first sentence here. A ball is projected horizontally, right, from a height. So the height is what? The height is what? 20 what meter, right? Now above the ground with an initial velocity. Now this initial velocity, now once you get projected, now it can either be vertical initial velocity or what horizontal initial what velocity, right? Now this initial velocity is called horizontal initial what velocity, which go to be what ux, right? My ux is what 0.4 meter per second, 0.4 meter per seconds. Can you see that? So I hope you understand these two statements here. So from this sentence here, we have derived this height and what initial horizontal what velocity, right? Let's say calculate the horizontal distance. Calculate the horizontal distance. That is the horizontal distance is x, right? It's x moved by the ball before hitting the ground. So now do what they say should calculate horizontal distance. And to calculate horizontal distance, here you have x equals to ut plus half at square. Is okay. So here we have u equals to ut Now this u here is what ux, right? Because this here is called initial horizontal what velocity, or horizontal initial what velocity, right? So if it's horizontal, the initial velocity is us, right? But if it's vertical, the initial velocity is uy, right? So this is what I want to use here. Remember, they didn't give us acceleration here. So acceleration is what is 0 meter per second what square. So it's not your fault. So the question did not give us linear acceleration, right? But we know that g acceleration due to gravity is always what 10 meter per second square. So how do we solve this here? We know this guy. We know the a is equal to what 0, but we don't know what our time. So how do we solve for time? It's okay. But what I want to understand here is that they didn't make any statement of what vertical initial what velocity. Now, because they didn't make any statement about vertical initial velocity here, my uy is equal to what 0 meter per second, right? Just like in my linear acceleration is what is 0 meter per second square, right? So the goal here is to what is to calculate time. The goal is, because if I want to calculate time, I can easily what solve my the horizontal distance moved by the ball before hitting the ground. Hope you understand. So which one can we use here? We have to use, because here, because you think about height, here we are going to h equals to ut, which is what uy, right? Uyt plus half gt square. Can you see that? Half gt square, right? So this is what I want to use to calculate. The mission is to calculate what my time. That is the main mission. Once I get my time, put it here, then I calculate what my, because this is the goal here. This is what they say what you should calculate. Do you understand? So yeah, remember uy, they didn't make any statement about vertical initial what velocity. So that why we make it about as 0, right? So now going to be my h is what is 20 equals what is 0 times t, right? Plus half times 10 times t what square, right? What up here going to be 20 equals to what 0. So if I ignore it here, 2 going to 10 is what is 5. So going to be 5t square, right? So if you have make t sort of formula, divide both sides by 5. Here we have t square equals to what 20 over what 5 give what 4, right? So what does this mean? It means that my t equals to what square root of what 4, which is what 2. So my t is 2. Just as so my t I've calculated, which is your time is what is 2 seconds, right? So from this one here, I've already got to what my time, given time it takes to what hit the ground. Hope you understand. I've already calculated what the time it takes to reach to hit the ground. So up here, I'm not start solving this one here. So pause the video and take this down so I can solve this guy. So what are you going to do here now? Right? So remember they say you should calculate distance, right? So it will be x equals to my ux is what is 0 times. No, my ux is what is 0.4 times my t is 2 plus half times my acceleration is 0, because they didn't say anything about linear acceleration. So they didn't say, since we were not giving initial linear acceleration is what is 0 times, then we have 2 square, right? Here you have 2 square. Now because of this 0 here, everything here will be 0. This that. So my distance is going to be 0.4 times 2, we're going to be on 0.8 what meter. That is the answer. Do you understand? That is the answer. That is the answer, as easy as that. So now let me just change it to what? To 58 meter. Now let me just change it to 2.4 meter per second, right? So now go ahead and solve this one for me. I've changed the value. Use pause the video or go over the video again in case you don't understand. Now then solve this question for me, right? I hope this video is helpful. If this video is helpful, please leave a question. This video is helpful, right? Thanks for watching. See you in my next video, which is going to be the part 2 where I'm going to use those formulas, those projectile formulas to solve more problems so that you can know understand it better, right? Thanks for watching. See you in my next video.